Good morning to all of you. Myself, Professor NV from SND College of Engineering and Research Center, Yeola, working as an assistant professor in Electrical Engineering Department. So, today we will start the new topic of course, that is numerical methods and computer programming. The solution of linear simultaneous equation. This is the new topic we will start in that lecture. What is simultaneous equation? In that there are two or more equations having two or more unknown values. Then to find the value of that, to satisfy this equation, it is called as simultaneous equation or linear simultaneous equation. Then the number of methods which is used for finding the solution of linear simultaneous equation. The number of methods are iterative method and direct method. In direct method, the Gauss-Jordan method, Gauss elimination method and Gauss-Jacobi method, and in iterative method, Gauss Seidal method and Gauss-Jordan method. So in that lecture, we will discuss the topic that is iterative method. In that Gauss Seidal method. What is iterative method? Gauss Seidal method. It is an iterative method. Iterative method means in that method, the solution of simultaneous equation find out by using number of steps. With the help of initial value. It is called as iterative method. The basic principle of that method is it can be solved algebraically each linear equation for xi. Assume an initial guess solution array. Solve for each xi and repeat. Means xi. It is the I is the number of iteration. That is x1, x0, x1, x2 up to the number of iteration. Up to the nth number of iteration. The initial guess solution array means the initial guess of all the unknown variables. That is, suppose x0, x1, x2, x3 or x, y, z. These are the unknown values, and the having initial values of both all the elements, that is x0, y0 and z0. Solve for each iteration and repeat the procedure and find the relative approximate error. After the completion of each iteration. And find out the error and check this error which is less than the pre-specified tolerance. which is less than the pre-specified tolerance. Means suppose iteration 2 value and iteration third value, both the value, the difference between these two values is very small and this is less than the tolerance value, then the iteration 3 is a final value of the final solution of the simultaneous equation. Why we choose the Gauss Seidal method? The Gauss Seidal method allows the user to control round-off error. Control the round-off error. Means in that method, we control the round-off error by using the number of significant digit which is used in the solution greater. As the greater the number of significant digits, then lesser is the round-off error. Then lesser is the round-off error. Elimination method such as Gauss elimination method and LU decomposition are prone to round-off error. In that method, the round-off error are present. Also, if the physics of the problem are understood, a close initial guess can be made, decreasing the number of iterations needed. Means, by using the physical problem solving, we can choose the initial value. The initial guess of the variable which is near to the final value. Then due to that, the number of iterations required to find the solution of this equation which will be less. The algorithm which is used for the Gauss Seidal method is, this is an three equations, a11 x1 plus a12 x2. These are the n number of equations, a11 x1 plus a12 x2 plus a13 x3 up to a1 n xn is equal to b1. Similarly, a21 x1 plus a22 x2 plus a23 x3 plus plus a2n xn is equal to b2. an1 x1 plus an2 x2 plus an3 x3 plus plus an xn is equal to pn. Then, if the diagonal elements are non-zero, then rewrite each equation for solving the corresponding unknown. First equation solve for x1, second equation used for solve x2 and so on. Then rewriting the equation 1 to equation up to the number of unknown values. Then from equation 1, x1 is equal to b1 minus a12 x2 minus a13 x3 minus a1n xn divided by a11. Instead of this c, this is the b value. This is typing mistake. x2 is equal to b2 minus a21 x1 minus a23 x3 minus minus a2n xn divided by a22 up to the number of solution unknown values. This equation we can find out. Then x1 is equal to b1 minus summation of aij xj. It is from j is equal to 1 to n, but j is not equal to 1 because the x is that. Suppose x1 is taken, then don't find the x1. Then x2. J is not equal to 2, j is equal to 1 to n. A2j, xj, bn minus 1 minus j is equal to 1 to n, j is not equal to n minus 1 and j is not equal to n. Only difference is that other are the both are the same. This is the algorithm to solve the simultaneous equation by using Gauss Seidal method. How or where can this equation be used? Solve for the unknown values of x. Assume the initial guess x. The important is remember to use the most recent value of xi, which means to apply values calculated to the calculations remaining in the current iteration. Means to use the most recent value of xi, that is suppose x1, we will suppose we find the x1 value, then which means to apply values calculated to the calculations remaining in the current iteration. Suppose x1 value is find out, then to find the x2 value in that equation, the x1 taken is that the x1 is not taken the initial value of the x1, but take the values of x1, which will be which is find in that in the same iteration, in the same iteration. This is your the difference. Only a main important things which is used in that method. Then calculate the relative error xi nu minus xi over divided by xi nu into 100. Suppose the value of relative approximate value error, it is less than the predefined tolerance of for all unknown, then we can stop for solving the number of iterations. But if the error which is greater than the tolerance value, then we can find next iteration. We can solve the next iteration. So we take a one simple numerical. The upward velocity of a rocket is given at three different times. The table in that velocity versus time data. Time is in second and velocity in meter per second. The time is 5, 8 and 12 and velocity is 106.8, 177.2, 279.2. The velocity of data is approximated by a polynomial equation as v of t, that is velocity at the time t is equal to a1 t square plus a2 t plus a3. Put the values of t and v of t in that equation, then we can write the three different equations. Then we can write the three different equations in the form of a1 t square plus a2 t plus a3 is equal to v of t, and the range is 5 to 12. The time range is 5 is less than equal to t and it is equal less than or equal to 12. Then using a matrix, that is write this equation in the form of matrix a1 t square plus a2 t plus A3, A1 T1 square, A2 T1 plus A3 is equal to V1. In that, and this equation which will be right uh, in the form of matrix template T1 square, T2 square, T3 square, T1, T2, T3, 1, 1, 1, A1, A2, A3, V1, V2, V3. A1, A2, A3 are the unknown values of the simultaneous equation, and we will find the value A1, A2, and A3. And the initial guess is 1 to 5. 1 to 5. Then put the value of T1, T2, and T3 in that matrix and find the answer. T1 is 5. 5 square is 25. T1 5. T2 is 8. T square is 8 square 64. T3 is 12. 12 square is 144. Again, V1, V2, V3, 106.8, 177.2, 279.2. Then you can find the values of A1, A2, and A3 from the equation. Write the equation. A1 is equal to 106.8 minus 5A2 minus A3 divided by 25. 106. Then instead of that, we can write simply the equation. आपण method use करू शकतो किंवा other method is put the values in that equation and write simple equation. Suppose first equation is for the value of 5 is 25A1 plus 5A2 plus A3 is equal to 106.8. Then A1 is equal to 106.8 minus 5A2 minus A3 divided by 25. This will be easy for making the equation of A1, A2 and A3. For A2 is 177.2 minus 64A1 divided 64A1 minus A3 divided by 8, and A3 is equal to 279.2 minus 144A1 minus 12A2 divided by 1. These are the simple equations. Find out from the given equation. Then iteration number 1. Applying the initial guesses and solving for AI. Then for finding the A1 is equal to 106.8 minus 5A2. Put the value of A2 is 2 and A3 is 5. Then 106.8 minus 5 into 2 minus 5 divided by 25. By solving this, the A1 value is 3.6720. 3.6720. A2 is equal to 177.2 minus 64A1 minus A3 divided by 8. Put the value of A1 as a 3.6720. Not taken the value 1 because this is important line. To use the most recent value of xi, which means apply values calculated to the calculations remaining in the current iteration only. Now from that, we use the value of A1 is 3.6720 minus 5 into value A3 is 1. Then by solving this, minus 7.8510 minus 7.8510. This is the value of A2. Then A3 is equal to 279.2 minus 144 A1 minus 12 A2 divided by 1. Put the values of A1 and A2 in that equations only. 3.6720 minus 7.8510, that is minus 155.36. When solving A2, how many value of initial guesses value were used? Find the relative approximate error of both A1, A2 and A3. For A1 is 72.76%, A2 is 125.47%, and A3 is for 103.22%. The new value minus initial value divided by new value. Then from that we can find the relative error. So the error is very large. So we solve the next iteration number 2, having the value, taking the value of A1, A2, A3 is 3.6720, 7.8510 minus 155.36. Then put the values of A1, A2 and A3 in that equation A1. Find the answer is 12.056. A2, in that A2, put the value of A1 at, this is 12.056 and A3 is minus 155.36. Then the answer is minus 54.882. And A3 is equal to 279.2 minus 144 A1 minus 12 into A2. Put the value of A1 is 12.056 and A2 is minus 54.882. And by solving this, A3 value is minus 798.34. Again, find the relative error. This is 12.056 minus 3.6720 divided by 12.056 into 100 is 69.54%. For A2 is minus 54.882 minus 7. Minus into minus 7.8510 divided by minus 54.882. It is 85.69%. This is 798.34 minus 155.36 divided by 798.34. It is into 100, it is 80.54. The maximum absolute error is 85%. Then the error is, means in that after the iteration number 2, the error is maximum. So take a next iteration number 3, 4, 5 and 6, and solve the values of A1, A2 and A3. Then A1 value is, final value of A1 is 3322.6, A2 is minus 19049 and A3 is minus 249580. The relative errors are not decreasing. It means the initial values are, the solution is not converging to the true solution of the equation. Means the initial guesses are wrong. Initial guesses are wrong in that method. So in that next problem, the second problem is Given the system equations, 12x1 minus 3x2 minus 5x3 is equal to 1. x1 plus 5x2 plus 3x3 is equal to 28. 3x1 plus 7x2 plus 13x3 is equal to 76. The coefficient matrix is 12, 3 minus 5, 1, 5, 3, 3, 7, 13. With the initial guesses of x1, x2, x3 is equal to 1, 0, 1. Will the solution converges using the Gauss Seidal method? Means solve this simultaneous equation by using Gauss Seidal method with the initial guesses is 1, 0, 1. 1, 0, 1. Checking the coefficient matrix, it is diagonally dominant. Suppose A11 is 12, A22 is 5 and A33 is 13. Which is greater than or equal to A12 plus A13, 3 minus 5, 3 and minus 5, 8. For 5 is 1 and 3, 4. 13 and 3, sorry, 3 and 7, it is 10. Means the diagonal values are greater than the summation of the other two values in the same row. Means the solution should converge using the Gauss Seidal method. Using the Gauss Seidal method. Then rewriting the equation, x1 is equal to, then x1 is equal to 1 minus 3x2 plus 5x3 divided by 12. Minus 3x2 plus 5x3 divided by 12. x2 is equal to 28 minus x1 minus 3x3 divided by 5. x3 is equal to 76 minus 3a1 minus 7, 3x1 minus 7x2 divided by 30. The initial guesses is 1, 0, 1. Put the value of x2 and x3 in that first equation. x2 is 0 and x3 is 1. Then 1 plus 5 divided by 12 is 6 by 12 is 0.5. x2 is, put the value of x1 and x3. x1 value is 0.5 and x3 value is 1. Then 28 minus 0.5 plus, sorry, minus 3 into 1 divided by 5. Then 24.5 divided by 5 is 4.9. For x3, for x3, for x3, 76 minus 3x1 minus 7x2 divided by 13. Put the value of x1 as the 0.5 and x2 as 4.9. Then 76 minus 3 into 0.5 minus 7 into 4.9 divided by 30. Then is equal to 3.0923. 3.0923. This is the value of x1, x2 and x3 after the iteration number 1. The relative absolute relative error is 0.5 minus 1 divided by 0.5. It is into 100. It is 100%. 100% error is available. For iteration number 2, the initial values is 0.5, 4.9 and 3.0923. Then put the value of x2 and x3 in that equation. x1, 1 minus 3 into 4.9 plus 3 into sorry, plus 5 into 3.0923 divided by 12 is equal to 0.14679. Put the value of x1 and x3 in second equation, that is x2 is equal to 28 minus 0.14679 minus 3.0923 divided by 5. Then the solution is 3.7153. काय हो माहिती